In part 1, we saw the basic structure of the while loop, and we wrote a little program that draws a row of objects. So here's the program. It's exactly the same as the one we just looked at, except I've added one line at the end, a print line, to say all done, just so I can point to what happens when the loop is finished. Down at the bottom, I will draw our graphics window. And just so we can sort of read off the X values, I'm going to put a little scale at the bottom, and I'll mark it off with the numbers 0 to 700, and I'll put these alternating pink and yellow boxes at the bottom. Those are 100 pixels wide, and that way we can always see where the circles are being drawn. So that's just a little ruler so we can see what's happening. In the middle, I'm going to keep a record of the 3 variables that really interest us in this routine, and in fact the only 3 variables we have: num circles, drawn circles, and circle X. And in these blue boxes I'll put their current values. So with all of this set up, let's actually run the program. So the way I'm going to indicate that we're running the program is I'm going to draw this orange arrow, and it points to the line we're about to do. So the first thing it does is it starts with this line. I mean, there might have been lines before, but we're at this point now. And it says, oh, I need to create a new variable. It's an integer. It's called num circles, and it has the value 6. So great, we stick the value 6 into num circles. Next line. We create an integer. Its name is drawn circles, and it starts with the value 0. So we stick a 0 in there. And then we have a float called circle X, and it has a value of 100. So we stick 100 in there, and we're done setting things up. Now we move to the while step. So processing sees the word while, and it says, okay, I'm starting a loop. There had better be an open paren and a matching close paren, because it absolutely always expects that. So it finds the open and closed parentheses, and it looks at what's inside. And it says, is this thing true or false? Well, what is it? It's drawn circles less than num circles. Drawn circles is 0. Num circles is 6. 0 is less than 6. That's true. So processing says, great, I will execute the statement that follows this test. If there's just one statement, I'll do that. If there's an open curly brace, I'll do everything until the closed curly brace. In this case, we have the curly braces, and it says, okay. I'll execute the first one. The first line says, draw an ellipse using the current value of circle X. And, there's a Y and a couple of values to control the radius. So sure enough, we draw our circle. The next line says, add 100 to circle X, so that the next circle will be at 200. So okay, we blow away the old value of circle X, and we fill it in with 200. Next line says, add 1 to the value of drawn circles, because we've drawn 1. So okay, now drawn circles is 1. And we hit the closing curly brace. What does processing do? It says, I'm going back to the top of the loop. And the top of the loop is the while statement. So it goes back up to the while, and it actually goes right back to that line and starts all over again. It says, all right, here I am at a while statement. What do? I test the value of drawn circles less than num circles. Well, 1 is less than 6, so this is true. It says, okay, I'll do the next thing. I draw the ellipse, so there it is. It goes to the next line. It says, add 100 to circle X. So we fill that in. It goes to the next line. It adds 1 to drawn circles. And now it has the value 2, which is right. We've drawn 2 circles. And it reaches the closed curly brace. So what does it do? It goes back to the top of the loop. It goes back up to the top of the while. And it says, well, I know what to do. I look for the test and I evaluate it. Right now, 2 is less than 6. And so I will do the following steps. Well, you know what happens now. You get the rhythm, and this happens over and over. We're not going to walk through this all 6 times. Let's jump to the end. After this has happened 6 times, let's look at the variables in the middle. Num circles is 6. Well, it's always 6. We set it up. That's how many we want to draw. Drawn circles is now 6, because we have actually drawn 6 circles, and there they are at the bottom of the screen. And circle X has the value 700. That's where the next circle will be drawn if we draw another. And at the moment I've captured the state of the program, we are looking at the closing curly brace. So we know what happens when processing hits the closed curly brace. It goes back up to the top of the loop. So it goes back up to the while, and it says there must be a test. It finds the test. And now the test is not true. Drawn circles is 6, num circles is 6, and 6 is not less than 6. It's really just that easy. The test is now false. So processing says, well, the test is false. I am done with this while. I'm going to jump down to the line that follows the closing curly brace after the end of the loop. In this case, it's print line all done. It'll print that out. And the while loop is history. We just move on from here. Of course, if this is all wrapped up inside of a draw routine, it'll all happen again when draw gets called. But in terms of executing the loop, it runs. When the test becomes false, it jumps to the end of the loop, and the loop is over. That's really all there is to it. Let me show you an example of using a loop like this to draw a picture. Here's a processing sketch that draws a bullseye using a series of circles with changing radius. In the next few videos, we'll look at code for working with while loops. Here, I'm just going to show you an example of what you can do. I've got a while loop, and inside the loop I make radius smaller each time, and each time I make radius smaller, I change the color of the circle and also its center. I can drag the center of the yellow circle around using my mouse, so you can see that the circles are indeed moving towards the center of the yellow circle. In fact, I can even move the yellow circle outside of the red one. It doesn't care. It's just moving towards wherever the yellow circle has been placed. So here I only have a few steps, but this is the beauty of the while loop. If I want to make this picture look smoother, I don't have to change my code at all. I only have to tell the while loop to take more steps. So I'll do that, and you can see I get a smoother picture. And if I do it again, I get a smoother picture still. And if I do it a few more times, it gets smoother and smoother and smoother until it's so smooth that on my screen right now, at least, it looks perfectly smooth. There might be some encoding artifacts, but it's looking just gorgeous to me. And if I let go, it looks like a sphere with a highlight. Now, it's not exact, it's kind of a hack, but it does the trick. Of course, it starts to break down as I move closer to the edge. If I get real close to the edge, it doesn't really look so much like a sphere. And if I go outside of the red circle, it's not a sphere at all. But I can always come back in and make it look a little bit more correct. And I can always change the number of steps. And here I'll back off on the number of steps again, because maybe for artistic purposes, I don't want so many steps. Maybe that's the number I want because this is the picture I want to make. That's the beauty of the while loop. You can take lots of steps and you can change the number of steps. I was just using the keyboard to increase or decrease the number of steps it took on the way from red to yellow. So one of the beautiful things that loops do for us is they give us the chance to experiment and see how many steps we want until our image looks the way we want it to look. So if, for example, in this image, I just thought, I wish I had a few more steps, I can just do it. And if I thought, I want fewer, I can do that too. So I really encourage you to have fun with these things. Once you learn how to use loops, you will use them in everything you do. They're like if statements. They're just indispensable. One thing I want to point out to you is something that will happen to you eventually, which is you will write a test that never becomes false. You'll just make a typo somewhere. So for example, in this program, my loop ends when radius is equal to 0. And that works because every time through the loop, radius gets smaller. Suppose I made a typo, and every time through the loop, radius got bigger. Well, it would never be less than 0. That means that the while loop would never stop running. So processing would never finish drawing even a single image. And once you ran the program, it would look like the program was just freezing up. It would be unresponsive, and your computer would just seem to not even be talking to you. When that happens, you have an infinite loop. That's the name of it. It means that your loop will run for an infinite amount of time because it will never stop. Don't worry about it. It happens to everyone. Either click the go away box in your graphics window, or if that doesn't work, and often it won't, go into the processing window itself and click the stop button, and then go in and fix your loop. I encourage you to give loops a shot. Once you get the feeling of them, You're going to love them.